Welcome and thank you for joining me in this lesson. We're about to start the second unit on vectors, where we'll learn about the equations of lines and planes, and also find the intersections made between two lines, between two planes, and between a line and a plane. In the first lesson, our focus will be on equations of lines in 2D space. Remember that you've been introduced to equations of lines way back in elementary school and revisited the concept every year in high school. And we've said that the equation of a line can be described in two different forms: slope y-intercept, or y equals mx plus b, and standard form, ax plus by plus c equals 0. In slope y-intercept form, we are given the slope and the y-intercept of a line in the equation. So m represents slope and b represents the y-intercept. In standard form, we have all the terms to one side of the equation, and it is very important to emphasize that b and c are integers, and the value of a must be a whole number, which means that a can be anywhere from 0, 1, 2, 3, so the positives, including 0. Now, both forms of equation can be found by either using 2 points or a point and a stop. And I'm going to stop here for a second to explain something very important. If someone asks you to draw a line, a specific line, then you would say that, okay, so I'm going to need a starting point to draw the line. But in order to continue or to draw the unique line or a specific line, we also will need to know the direction of it. So we're going to say that in order to draw a line, we need to know a point, and we need to know in what direction to go. And obviously, remember that we extend the line in both directions because the line continues both ways. That's why we draw 2 arrows at each end of the line. Another way of writing or drawing the line is if we have 2 given points. So if we have 2 given points, then we can define uniquely the location of a line. So just like in drawings, like physically drawing the line, when we algebraically try to find the equation of it, we are going to need either a point and the direction, or we're going to need to know the 2 points on the line. So in the first example, we're just going to review together how to find the equation of a line when a point and then a slope is given, or when 2 points are given. And actually, I'm going to start with example 1b because that is a little bit more basic. So in the first, question 1b, we are given that the line passes through the point 3, 4, and negative 1. And it has a slope of negative 1 over 2. We're asked to find both the standard and the slope y-intercept forms of the line, and it's best to start with slope y-intercept form. I like to write the equation first, y equals mx plus b, and then revisit the information given. So I am given the slope, which is negative 1 over 2. And I'm also given a point on the line, 3/4 and negative 1. In other words, I am given the x and the y coordinates of a point that satisfy or must satisfy this equation. So for y, then, I'm going to write the value of y, negative 1, and for x, I will write the value of x, which is 3 over 4. With all the information given now, I'm going to rewrite the equation. Negative 1 equals negative 1 over 2 multiplied by 3 over 4, and then plus b. Simplify each side, so that would be negative 3 over 8 plus b, and then solve for b. So the value of b is negative 1 plus 3 over 8. So we're going to write negative 1 as negative 8 over 8 plus 3 over 8, which equals negative 5 over 8. Now that we know the value of b, we can write the equation with confidence. So we'll say y equals mx plus b is y equals negative 1 over 2x, and then plus negative 5 over 8, which is minus 5 over 8. And this will make the slope y-intercept form of the line. Now, to write the standard form of the line, we are going to use the equation we just found, which I will rewrite one more time, and take all the terms to the left side of the equation. So first we have to start off with the x term. So 1 over 2x comes from transferring negative 1/2 to the left side, which means that it changed signs. And then we have plus y hasn't changed sides, and negative 5 over 8 becomes positive 5 over 8 equals 0. Another thing we need to take care of is the coefficients. So the coefficients must be all integers, and the first one has to be a whole number. So for this, we are going to eliminate all the denominators by multiplying every term in the equation by the lowest common denominator, which in our case appears to be 8. The lowest common denominator, remember, is the lowest common multiple of all the denominators. So the smallest number that is divisible by every denominator. So 8 will multiply 1/2 x. 8 will multiply y over 1, or y. And 8 will also multiply 5 over 8. Equals 0, and that will bring the equation to 8 over 2, 4, so that's 4x plus 8y, and then plus 5 equals 0, and this would be the standard form of this same equation that we just found before in slope y-intercept. So we're going to move on to the next part of this example, example 1a. This time we are given the coordinates of 2 points. Again, I'm going to start off by writing the equation y equals mx plus b. That's what I'm trying to find here. And to find the slope, I have to use the slope formula. Remember that that's rise over run. Easy and fun, right? Just remember to rise and then run, which is basically delta y over delta x. I will be a little bit careful here when I write the expression for the slope because I'm dealing with the fractions. And here we go. We have y2, 1 over 2, minus y1, which is minus negative 3. So you can treat them as x1, y1, x2, y2. Sorry, I'm leaving out some details, but I'm explaining this as if it's explained to a grade 12 student in the meantime. So this would be 3/4 minus 1 over 2, and here we go, 1 over 2 plus 3. And for 3, I'm going to multiply by 2 over 2 because I have to add 3 to 1/2, which means that I'm going to have the same, I'm going to need the same denominators, right? And the same thing will apply to 1 over 2. I'm going to write with denominator of 4 in here. So this would be equal to 1/2 plus 6 over 2. And obviously, we don't have to show so many steps, but I'm just trying to explain this, so skip ahead if you wish. And that would be 7 over 2 divided by 3 minus 2, 1 over 4. And division here will turn into multiplication, which will flip the denominator. And that would be 7 over 2 times 4 over 1, which will leave us with a slope of 14. And now that we know the value of the slope, we're going to write that the equation y equals mx plus b with a slope of 14. And we're going to pick any point in here in order to find the equation of the line. So we can pick either a or b, but I'm going to pick a in here because it has fewer fractions for coordinates. So x equals 1/2 and y equals negative 3, which means that I can replace x by 1 over 2 and y by negative 3. And we have to find the value of b. Sorry, here we go. So negative 3 equals 14 times half is 7 plus b, and then it seems that the value of b is negative 10. So with a b value of negative 10, then I'm going to write the equation in slope y-intercept form, which is 14x minus 10. Now that we know the slope y-intercept form, we can convert this to standard form. So this would be negative 14x plus y plus 10 equals 0. I'm taking all the terms to the left side of the equation. And now we have to make the denominators, the leading coefficient or the coefficient of x positive, because that's a rule, that's a standard form. And we can do this by either dividing by negative 1 or multiplying by negative 1 every term in the equation, or simply switch the signs of every term. So negative 14x turns into 14x, positive y into negative y, positive 10 into negative 10 equals 0, and voila, this is the equation of the line in standard form. So the equations that we just found here, so both slope, y-intercept, and standard form, are what we call the scalar equation of a line, or the Cartesian equation of a line. So they have a special name, and the reason why we are giving it a special name is because in this unit, since we're doing the unit of vectors, right, we are trying to describe the lines using vectors. So the equations of lines that we have learned so far are what we call the scalar or Cartesian equations of a line, and they can be written in either slope, y-intercept, or standard form. And now we're going to transfer this same concept to to find the equation of a line using vectors. Now, in order for us to be able to understand how to find the equation of a line using vectors, we need to be able to know how to draw a line using vectors.